So we can also use systems to help us solve network flow problems. Well, what is that? That's the first thing to ask ourselves. Well, a network is a system that's made up of junctions and branches. So what's a junction and a branch? If I look at my image down here, a junction would be the point, and the branches where are the lines that come in and out of that point. And what we know is that whatever comes into our junction has to equal the amount of flow that goes out as well. And that's for the entire network as well as at each junction point. So if I look at this image, whatever inputs for x1, that total amount has to be the same output as 30 plus x2. So what I know is that x1 has to equal x2 plus 30. So say that I inputted 50 for x1, that would mean x2 would have to be 20 because 20 plus 30 has to equal 50. So here's an example of how this could work and how we could use systems to help us. So say this is a traffic flow pattern in a small town and it's covered for over an hour. And they want to know what's the most vehicles that one would expect to actually go through the branch of x3 from point B to point A. So the first thing to help us start would be to actually create the equations that exist at each junction. What's the input and what's the output, and set them equal. So if I look, I have at this junction here 80 coming in, and that has to be equal to its output of x1 and x2. The second equation there, I have coming into junction A x1 and x3, and the output there is 60. And then if I look at junction B, I have the input of x2 and the outputs of x3 and x4. So there's my three equations. Now I want to rewrite them so that they make a little bit more sense by putting the variables on the left side and the constants on the right side, and then I can use systems to help me solve this problem. So here's my rewritten equations, and pay attention. For me, I wrote them by subtracting the x3 and the x4 to the other side, so the x2 was the positive. And now I can plug that into the augmented matrix, and I can use Gauss-Jordan elimination to help me solve this and find out what's the value of each of my variables. So let's row reduce this. So first thing I could do, I could subtract row 1 from row 2, and then I could go through and do row 3 plus row 2. Now I want to keep going, so I'm going to add row 1 and row 2 together. And last thing, I see that there's nothing else I can cancel, but I want my leading ones to be positive. So I'm going to change both of those, multiply both those rows by a negative so that the leading ones become positive. And now I have my augmented matrix simplified down to where I can work with it. So what does this mean? Well, I'm going to rewrite them as equations. This tells me that the first line gives me x1 plus x3 equals 60. Then I've got x2 minus x3 equals 20. And this last one is x4 equals 20. So what that means is there's no leading coefficient for x3, so x3 is a free variable. So I want to rewrite my equations for x1, x2, x3, and x4. So I'm just going to shift the x3s on the first two equations, so that x1 is equal to 60 minus x3, x2 is equal to 20 plus x3. Now the question came back to what is the most that I might expect to see traveling through x3. So I got to consider what's happening in the situation. And I got to think about what are my restrictions on my input and my output, since they have to be the same. Well, I know that my input has to be 80, and my output here is 60, my output over here is 20. So if my input here to point C is 80, I got to think, is there a restriction about how that 80 is split? And in all honesty, there's not. So it could be that I send all 80 cars through X2. And if I do that, then I have to think about, well, what happens when I get to junction B? 20 automatically have to go to X4. That's what this tells me. And then the rest will go through X3, which means that if all 80 went through X2, 60 cars would have to go through X3, and that would mean 0 cars went through X1. So 0 plus 60 would equal the output of 60. So that would be possible. And if I think about my equation, 60 minus the 60 that went through x3 would mean that x1 is 0. So it all works together. So the most cars that could potentially go through x3 would be 60 cars.